In this video, we're going to work with some data that can be used to create this three-legged stool that you can see on the screen. The design for this was supplied to us by Bill Young, and we'd like to thank him for allowing us to use it. The way that this design works is that it will slot together using kind of a mortise and tenon style joint. We're going to show you how we can import the Dxf file that was created in another CAD system where this part was designed, some of the issues that you may need to address when importing a Dxf file, and then how we can prepare the part to make it manufacturable. In this case in particular, we're going to look at a feature called dog bone filleting. This is a way that we can edit square corners on the part to allow them to be cut with a round tool so that these mortise and tenon style joints will work correctly after the part comes off the machine. We're also going to look at how we can take the data once we've finished editing it and prepare it to cut multiple parts out of a sheet of material. In this case, we're going to ultimately end up with the data to cut 6 of these stools out of 2 sheets of plywood. So let's go ahead and begin by starting a new copy of the software. So let's begin by clicking on the icon to create a new file. We're going to set this job up to effectively be the size of a piece of plywood that we're going to use to lay out and cut our stool design. So this is going to be a width of 96 inches and a height of 48 inches. Material we're going to use is 3/4 inch plywood, 0.75, and we're going to set the XY datum position to be in the lower left hand corner, ready for our machining once we've finished doing our layout. Let's check units are set to inches. Go ahead and hit the OK button. So to import our data, we're going to click on the icon under the File Operations area of the Drawing tab, which is called Import Vectors from a File. This is going to allow us to import our stool data. In this case, we have it as a Dxf file. Dxf is a common file type which can be saved from lots of different CAD drawing programs. We can also import file types such as DWG, APS, AI and PDF that can be saved from lots of different design programs, everything from CorelDRAW, Adobe Illustrator, Inkscape and many others. Here we're going to select our Dxf file and hit Open. And at first nothing appears to have happened. And what's actually occurred in this case is that our data has been saved from the other program in a position where it's not visible in the current view we have within our part. Now this can be a reasonably common occurrence depending on how the part was drawn and where it was drawn. We might be able to see it if we were able to zoom out from the part. So in this case I'm just going to put the mouse cursor in the 2D view, and I have a wheel mouse, so I'm going to roll the wheel towards me and zoom out in the 2D view here, and we can see the data where it's been imported again, and that's based on where it was saved from in the original program. So you may not have control over this. It may be data that's been sent to you from a customer, and so when we've imported it, it wasn't visible in the main 2D view. Now if this happens and you can't see your data, then the best way to deal with it, assuming that the original position of the data is not critical, is to just center it within the middle of the part. So if we go back to our standard view so we can not see the data that's been imported, I'll show you the process that you'd use to center it. To be sure that the data was selected, and it should automatically be selected when you import it, but just to double check that, in case maybe you've clicked off the data or something, you can come up to Edit, select all vectors, and then you can go ahead and choose the Align Selected Objects icon from the Transform Objects area of the form, and come up to Align to Material and choose the middle of these 3 at the top here, which will align both horizontally and vertically within the part. And there we can see our data has been aligned in the middle of our job setup. So we've seen how the position of the part can be affected by how it was saved in the original sending system. In addition to that, for Dxf and DWG files, you will also import any layer information that the part was saved with. If we come down and click on the Layers tab, we can see the part we've got here, and the three layers that the data is on. We can tell which layers have data on by looking at this third icon for each layer and seeing if it's got the little shapes on it. That shows me that there's data on that layer. So layer 1 was the layer that we had in the software by default, so if we were to make that invisible, we'll see there's nothing that disappears. Layer 0 is one we've imported, but there happens to be nothing on that, and it may be that you do import layers that don't have anything on them. It just depends how the part was set up and exported from the sending program. In this case though, the data is on three different layers for organization. There's one with the top part, one with the vertical parts, and one with the base part. For this particular job, this is not going to affect how I'm going to work with this. However, it may be that depending what you do with your layers, you might need to reorganize the data. You may want to get rid of layers that don't have any information on them as well. There is a tutorial which is completely focused on layers and layer management, which I'd recommend watching if you'd like to learn more about how you can use the layers to help you keep your work organized. So as we're not going to manipulate the layers in this case, let's come back down and click on the drawing tab and let's consider our design. What I'd like to do at this point is just zoom in on the parts I've got on the screen here. There's several ways we can do this. We can zoom in using the zoom box, or because we already have the part selected, I can click on this icon here to zoom selected, and that's just going to zoom in on whichever selected objects I have chosen in the 2D view. So we'll click on that and we can see that just zooms in nicely on the parts we've got here. If we want to deselect the parts, we can just click in the white space, making sure we're not clicking on any other entity, and that will deselect anything that we've currently got selected. So a design is intended to be cut out and slotted together. If we just take a quick look at the original design picture, we can see how we've got kind of a mortise and tenon arrangements. Each of these vertical pieces has got a little tenon on the top of it, which is designed to slot into the mortise hole in the flat horizontal parts in order for this piece to slot together. In terms of the design, there's one element of this which is extremely important. We've set this part up to be cut out of 3/4 inch material. That means that when we cut around each of these parts, the tenons are going to be 3/4 inch thick, 0.75. That means that our mortise holes need to be made so they will fit together. So each of these slots has been designed so that its width, its height, as we're looking at this one, is 0.75 inches. If I select that vector, you can see at the bottom here is showing me the width and the height of that piece that I've got selected. It also gives me the layer information displayed here as well. So the idea is once these are cut out, that these will all slot together very snugly. Because of this relationship between the material thickness and the size of our mortise slots, if you were to change the material thickness, or if you were to measure your material and find out it wasn't exactly 3/4 inch, then you would need to come in and edit all of the mortise vectors. All of these internal vectors here would need to be changed so that their width or height, depending how you're looking at them, match the actual thickness of your material. Otherwise you wouldn't get a snug fit when everything was slotted together. There's also another issue that we need to be aware of when we come to manufacture this. We're going to cut out around our tenons and then want those to slot into the mortise. However, when we cut our mortise out in here, what we're going to be left with is an internal radius. If I draw a vector that represents the tool, so just a 1/4 inch diameter vector, and we were to bring that into the corner here, you can see that when this is cut inside of here, we're going to be left with this piece of material between the radius of the tool and this nice sharp corner. And that means that when we try and put our tenon in there, it's not going to fit. Now we could go round and hand finish everything if we wanted these to be like a true mortise and tenon joint. Or one of the things we can do with a CNC machine is to introduce something called a dog bone or a T-bone fillet, which will allow us to machine these in such a way that the part will still slot together straight off the machine. So let me just delete my imaginary tool outline there. I'm going to come back so the parts are zoomed out so we can see everything on the job setup. And let's now look at adding some of these special types of fillets into the corners of our parts. I'm going to select the outline for the top of the stool, and I'm going to go to zoom selected so we can see that clearly in the 2D view. And then what I want to do is come over, and from the edit objects area of the drawing tab we're going to choose this icon to create fillets. You can see there are a number of different types of fillets that we can add to our geometry. We've got standard fillet, and then the ones I'm interested in this case is the dog bone fillet and the T-bone fillet. And these are a special kind of fillet which is going to open up the corner and allow the tool to fit in and machine that out. What that'll mean is we're not left with any material in that corner, and so our tenons will slot together perfectly with our mortise. The only downside of this is we are left with a little area around the corner where we are going to have a hole. So certainly there is an aesthetic penalty to this type of joint. So here though I'm going to choose the dog bone fillet option, and what I want to do is specify the radius of my tool. I may even want to make it a little larger than the radius of the tool to give me a bit of an allowance. So here I'm going to cut this part out with a 1/4 inch tool, a 0.25 inch diameter end mill, and so the radius of that tool would be 1/8 of an inch, and I'm going to leave a little bit more than that, 0.135. So that'll just give me an extra little bit of play to make sure the tool will easily fit into the corners. To add a dog bone fillet, I'm just going to come over a corner, and it has to be a corner between two lines, and as soon as I move over that corner you'll see I get a little check mark appear on the cursor. So there, if I come up here you can see that check mark appear. Once I see that check mark, it means that the software's found somewhere where it's valid for me to add this type of fillet, and if I click it'll add that in there. So if I just roll the mouse wheel towards the screen, we can see how that's been added, and I could go around all these corners and add those dog bone fillets in. What this means now is that my tool will go in and clear out that area, and so now when I slot my tenon in there, there's not going to be any material to get in the way of that fitting together and creating a nice tight fit. So now what I would want to do, if I zoom out here, is basically go around all these internal shapes and add this type of fillet to them. So I may zoom in very carefully, or here, as long as I'm close enough to see that it's a valid point and see when I make the change, so I know for sure that I've added that in there, then this is very easy for me to do. So I'm just going to click around all of these. Now I'm going to hit F on the keyboard, which is the shortcut to go back to fit the entire job on the screen, and I'm going to zoom in on the base plate area and basically go around and just add all these in as well. Now at this point you may want to go ahead and just pause the video if you wanted to spend a few minutes adding these in yourself if you're following along. I always need to make sure that I can see the check mark before I click to ensure that I'm going to add that correctly. So again, I'm going to hit F on the keyboard to zoom out again. So related to needing these types of special corner fillets to allow the tenon to fit into the mortise, we also need them on the bottom of the tenon, if I zoom in here, to allow this part to fit completely up to the corner as well. Otherwise, if we have again a fillet of material left in here from the tool, then this isn't going to be able to go into the mortise until this surface fits flatly on the surface of this part. So we'll also need these dog bone fillets in all of these corners as well. So once more we might want to hit F on the keyboard, may just close the fillet menu for a second, take this, zoom selected, go back into the create fillets function, and using the same size, because we're going to use the same size tool to cut these out, we'll come around the outsides here, just add these into all these corners. Let's hit F and then zoom in using the mouse wheel. If we put the cursor in the area we want to zoom in and roll it away from us, we'll zoom in. Again, we'll just come along and add it into each of these. Same on this side. Hit F to fit the window again, and then just zoom in on this one. Click our last few locations. Hit F. So again, you may want to pause the video for a second while you go ahead and add those in if you're following along. And then there's also one other area where we need to add some of these areas in as well, and that's on these pieces that slot together coming down the middle of our part, so that the main vertical edges have this long vertical slot in them, which is all going to piece together, and we need to make sure that that also in the corners here has some kind of way of allowing these to fit flat against each other. So we can add the dog bone fillets into these corners as well, or just want to show you the other type of fillet we've got for creating more space to get this type of joint in here. That's a T-bone fillet. Typically you'd use these where the slot was not much wider than the tool, and so rather than having to have enough space where the dog bone might overlap enough that it would eliminate the flat surface at the bottom here, you can effectively grow the radius area out the sides to allow room for the tool in there to make sure that you still get this nice flat edge on the bottom. We could use in this case, if we want, for a aesthetic purposes. So if I was to choose a T-bone fillet option here, in this case what it will do is require me to pick one side or the other to add it rather than the corner. So if I click here, it will add it sideways. If I was to click here, it will add it in this direction. If we put it in the wrong place, as with any fillet, I can just come over it, and when I see the check mark and it shows me there, you see that I'm going to get the two straight lines again from the icon. So if I click on that, that'll just get rid of the fillet and I can add it back in on this side. So let's hit F to fit, come in and add these in here, 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 and here, and F to fit, and then finish off by adding them in here and here. Hit close, hit F to fit again, then once more we'll just select everything and just click the icon to zoom selected. So at this point we've added the special types of fillets into all the corners where we need to. If you want to pause the video for a second, you can go ahead and just double check and look around your part to make sure you've got them everywhere you need. Just zoom in and kind of scroll your way around in order to double check. It's always very important to make sure they're everywhere you need them to be. And if you were going to make these stools at this point, it would make sense to actually go ahead and position this onto a single sheet and machine one as a prototype to double check it. Here I'm going to assume that we're happy with our design, that we've cut a prototype and it works okay, and I'm going to show you how we would nest this data in order to make multiple copies of the same object. So in order to nest our parts, we're going to select them, I'm going to drag a box around them with the mouse from the 2D view, come over to the offset array and nest area of the drawing tab and click on the nest selected vectors icon. Within here I have a selection of parameters that I need to enter in order to define how the parts are going to be fitted within the material. There is a tutorial which specifically deals with the nesting if you want to review this function in detail. In this case, the first thing I'm going to specify is the tool diameter. I'm going to use a 0.25 inch end mill in order to cut these parts out. So I'm going to tell the software that so that it knows that spacing to allow for, and then I'm going to tell it I would like an additional 0.4 of an inch spacing to allow a bit more material to be left between my pieces when they're cut out. Not going to specify a border gap. What that would do is allow extra material around the edge of the part if I was going to clamp it or screw it down. In this case, we'll imagine we're holding the part down with a vacuum, so we don't require that. Going to let the part rotate the vectors up to 45 degrees to allow them to fit or to create a better fit. And then it's just a case of choosing from these other options here as to whether I allow the parts to mirror, allow parts inside of other parts, which I'm going to check off, although with this design there's not really enough space for that to happen anyway. Then I'm going to nest from the lower left corner, and I'm going to nest along the x-axis first and see how that looks. In this case I would like 3 copies, so I can either enter that, or if I hit the up arrow I can get 3 copies. I can hit apply. The software will show me the pieces that are going to be nested and how many times they're going to be nested, and at this point I can hit the preview button. When I preview this, it's going to show me, based on the parameters I've set, how the software thinks it can fit those particular parts within the material specified. So you can see in the 2D view 3 copies of our stool design. You can see 3 tops, you can see basically 3 sets of 3 for the vertical parts here, and then you can see 3 of these base pieces. Now it may be that we'd actually like to nest more copies. This will fit in a single sheet, but maybe I'd like to see how well I could nest 6 copies of this. So we could click on Reset Preview. That'll take us back to the point before we hit the nest button, or before we hit the preview button. We could say that I would actually like to see if I can cut 6 stools, hit Apply and Preview. What that's done now is it's created multiple sheets. We know that we wouldn't be able to fit 6 copies of this on one sheet because we were only just able to fit 3 copies of it on there. But if we were to click in here and just zoom out now, we can see that what we've created is this additional sheet of material when it's done our nesting. If we want to look at that sheet within the area of our material, we can either click from the option here, or we can just double click in the 2D view to alternate the data that is currently in the area where we're going to machine. In the companion video to this one, we'll show how we'll generate toolpaths for this part, swapping between the sheets to create different toolpaths for the different pieces of material that we would cut. In this case I'm happy with the way this is nested, so I'm going to come down and click on the OK button. We'll save this file, come up to File, Save As. I'm going to save it in the project folder, and I'm going to call this 3-leg stool vector.crv, and that's a file we'll open in the companion video and create toolpaths on. So just to summarize some of the things we've looked at in this particular tutorial. We started with the setting up the job and importing the Dxf file. We showed you that potentially a Dxf file may come in not within your work area, so you may need to adjust that, and also the fact you may pick up things like layer information from the part, and again just to be aware of that. Next we discussed the idea that the way this part had been designed was to slot together, and how that when we introduce the radius of the tool to cut this part out, we're going to create areas of material which would not be cleared out if we were to try and slot them together without allowing for them. The way that we allowed for them was to show you the dog bone filleting tool. So we went in, and on each of the corners where we needed to relieve that material and make sure the tool would be able to get in the corner in order to cut that out and not leave a radius, we added those fillets. We went round all those internal corners on the part, and then we showed you how we could generate the layout for this part if we wanted to create multiple copies of it. So we're able to enter 3 copies to fit on a single sheet, or ultimately what you can see on the screen here is the fact we've entered we'd like 6 copies of it, and use the nesting to automatically generate the layout ready for us to do the toolpaths in the companion tutorial.